Welcome, everyone. In this video, I will go through systems thinking, and in particular, I will be looking at the way that we think about problems and going from linear to feedback, and why this is very important, and how this is related and relevant to why dealing with symptoms when we are facing complex issues, complex problems, doesn't solve these problems. So the lecture today, or the video, is supported by material from a report that was published in 2004. And I've got the report in front of me that I will be using to talk through this topic. And it was published in 2004 by Haraldsson from the Department of Chemical Engineering at Lund University, and it's called Introduction to System Thinking and Causal Loop Diagrams. And just before I start, it's always important and useful to know how certain people think and how do they see certain topics and how do they conceptualize things. And in this case, Haraldsson conceptualizes systems thinking as principles of organization or theory of self-organization, and the way of using it involves systemic or holistic thinking. He considers it as a science based on understanding connections and relations between seemingly isolated things. So this is how Haraldsson, who is the author of the report, considered systems thinking. So, seeing structure and logic in problems. So, Haraldsson talked about problems in general in his the start at the beginning of the report, and he talked about something that he called end-of-pipe solutions. It's a really interesting concept because it is about how we humans are automatically geared towards curing symptoms. And this is what he called what he meant by end-of-pipe solutions. This is not intentionally done by policymakers, he says, but rather it comes from our lack of ability to understand how the symptoms manifest in the first place. So, and he used the example of coal-fired power plants, which are considered a problem. And these, because they cause a lot of pollution, and ultimately also they cause a lot of, what we are seeing right now in terms of they play a huge part in climate change. And he talked about that. He talked about coal-fired power plants as the problem, and how policymakers have dealt with this problem through filtering of smokestacks, which is a secondary issue, instead of as a source of carbon dioxide, and instead of actually dealing with the coal itself and the concept of coal. And how it feeds into the climate crisis that we're facing. So in this case, we are dealing with symptoms instead of dealing with the actual source. And he says that this is not obviously this whole dealing with symptoms is not unique to the power industry. It's also related to how our strategies in general. And he also used another example, which is, again, very relevant and interesting from a Northern European perspective. He talked about their experience of over several decades of high sulfur deposition as a result of industrial production. And this problem is often referred to, in other words, as the problem of acid rain. If you are not familiar with it, I would highly recommend, reading about it, maybe through Wikipedia or another way, or using, a book source or something like that. So this problem of acid rain or high sulfur deposition that they've had in Northern Europe over several decades It's a typical problem, he says, which has its source in one geographic region, but it is also transferred with winds to another region and deposited as well. And in the 80s, lake ecosystems in Scandinavia started to die off. They started to die due to increased lake acidity. And the immediate response to this problem at the time was to fix the symptoms of decreased lake acidity and initiate what they call lake liming programs. And this lake liming programs involved basically you pour calcium carbonate into lakes in order to reduce the acidity effects there. The purpose of the lake liming was to restore the original pH level in the lake to recover the initial ecosystem that was dying. But after several years of research, Haraldsson was explaining, and after several years of doing this whole, act of lake liming, they discovered that runoff from land was primarily responsible for acidity in lakes. So sulfur deposition on soil affected groundwater and runoff water, which then affected acidity in lakes. And as a result of that, decision makers initiated soil liming programs as a means to deal with and fix the worst affected areas. And some people started to ask if it would be more reasonable to address the problem at the source itself. And that means to deal with the industry that is primarily responsible for the sulfur emissions in the first place, rather than doing, this whole lake liming and dealing with the symptoms. And that approach was much more complex, and it involved much broader definition of the problem, which means involved the participation of the emission or emitting countries. And it was in this reasoning where you would see that this problem involves addressing the sources rather than just the symptoms. And it involves also involving all actors in the situation to address the problem. And he said, and this acid rain story is only one of many other similar ones. But he said Haraldsson was commenting that how politicians find themselves dealing with these really big problems, which often tend to be complex. They involve uncertainty. But there is not just politicians, everyone seem to be accepting. They reach a point where they accept the risk. In order to deal with these very complex big issues for them, since it involves just waiting, you just wait and see, and then you've got, election cycles that are normally very few years, they're not lifelong, say, in most countries, especially here in the case of European countries. So you just wait the problems, you just see it off, and there is that kind of attitude sometimes. And in this case, there is no decision. Nobody takes decisions, or in this case, drastic decisions, beyond dealing with the symptoms. So this strategy, unfortunately, prevails in these cases. And since the symptoms are a manifestation of our underlying problems, it is difficult to assess how large the problem is without addressing the uncertainty part of these problems. So this takes us to the transboundary, issue. So here, the pollution in this acid rain example is very clearly a transboundary problem. It is a regional problem that is impossible to deal with on a country level. It would seem, very reasonable for the emitting country to really take responsibility for part of the costs of the ecological degradation, And this sort of problem is impossible to deal with in the absence of other stakeholders in other countries or other areas, and also without increasing the system boundaries, which is something that I talked about in another video. If you go and check out my recent videos, you'll find it there. I talked about it and I explained using another source, what do we mean by system boundaries and why this is a huge problem for when it comes to systems thinking, when it comes to the models that we do, whether it is research, whether it is in practice, and also the solutions that we come up with for these very complex issues. So Haraldsson here goes back and really also talks about the system boundary issue that we tend to have when we are addressing our problems. We don't tend to think in a transboundary way. So when we view a problem on a local level, we only see the symptoms and often also dismiss the feedback to the doer, the person who is doing the action or the source of the problem. And this is not intentionally done, but it comes from our problem-solving strategy. And our problem-solving strategy is often based on linear thinking, which neglects the feedback and the behavior in our problems. So we become focused on treating the symptoms rather than dealing with the underlying cause in this case. So that takes us to our mental models and their limitations. So in terms of our mental models, Haraldsson talks about our limitations and we develop as humans, we develop routines and we develop skills that are based on our mental models to solve issues, to solve certain issues on a daily basis, and in the short term as well as in the long term. So, for example, he gives several examples. For example, you can drive early to work to avoid traffic, or you put on a jacket before you go outside because it is cold. You know that. You've come across this problem before, and you deal with it in a very linear and straightforward way by, okay, it's snowing, it's cold outside, so I better get a jacket or boots to protect myself. And these actions they involve instant changes, so instant feedbacks that I can observe, that we as humans, we can observe in time and also in space. So we base all of our decisions on our mental models. And since we often become so dependent on our routines, on our skills, we have difficulties to really steer away to detour, as Haraldsson said, from these in order to take in new understanding. So the human mind best understands models, he says, as linear and also as static, which describes a set of linear relationships that do not really change over time. If, for instance, we know that when it is cold outside, as I said before, we need to put on an extra sweater, as we know. And here, time is not really relevant to us, since we use the temperature to determine the amount of clothes that we need to maintain a comfortable temperature. And this is how our mind works in most cases. We simplify, these sort of issues, and in most situations. And we only encounter problems when our static representation of reality, our routines, our skills are inefficient to simplify the complexity of the real world that we live in. So this is why most problems This is because most problems are dynamic. And that means we've got variables. There are variables to these problems. There are also several relations that vary with time. And the most essential factors concerning, this dynamic behavior are the feedbacks. And we can estimate the amount. So we can estimate the amount of clothes that we need for certain temperatures. But our initial assumptions do not take into consideration, for example, fluctuations in temperature during the day, because it is not linked with time, with our perception of time. For example, the instant feedback of realizing that it's way too cold when we step out of the door of our house. So if we know that it will start to rain later in the day, assuming, we know the weather forecast, we start to link time to our mental model. And just to be on the safe side, we take a rain jacket with us. So you could see here in this very simple example that we create these mental models with a feedback in this case. So here, Haraldsson goes back to the human mind. The human mind really performs poorly when confronted with complex dynamic behavior that incorporates many variables and time lag. Usually we have no problem in grasping behavior of 2 or 3 dynamic variables or dynamic factors. But issues start to arise, they start to happen when we are confronted with variables that exceed 3 or 4 components that move dynamically with time. For us, the mathematics are just too complex to actually do in our minds to figure out how these variables, these variables are, the relationships between them. And at this stage, Haraldsson says that it is very important to structure our logic when we are confronted with these, many variables and many relations. It is really important to structure our logic such that we can identify what, how, and when to act in complex situations. And Haraldsson goes back to two main issues here of why we think that way, why we think in linear ways. Education, our traditional education teaches us that reality is made of linear relationships, but in fact, it is made out of circular arranged events. So we tend to see everything in straight lines. And also, we have also a linear view, which tends to put the individual at the center of attention rather than us taking the neutral approach. So if we want to master systems thinking, we need to give up on the assumption that there must be an individual or an individual agent responsible for the problem that we encounter in a system. So Haraldsson concludes this section by saying, when we work with system thinking, we need to work with the concept of feedback. Feedback is really responsible for changes within systems, and that means action causing reaction. Feedback here doesn't really mean opinion or encouraging points of view. Feedback means response to an action or inverse flow of influence in regards to an action. It is any action that causes an effect back to the starting point of the action. So feedback here is both the cause and it is also the effect. This is important to keep in mind in terms of the feedback. It's not just a cause, it's also the effect. The most important issue Haraldsson continues about the feedback perspective in systems thinking is the suggestion that everyone shares responsibility for the issues or the problems created by a system. Thus, because of that, no one factor is the sole responsibility for changes that we see in a system. So this really taps into how we think, and also ultimately how we conceptualize systems at the same time, how we conceptualize these feedback loops, and how we construct these circular connections and feedbacks, and to actually diagnose, to understand that system, to diagnose the issues that we are dealing with, to actually deal with these problems. So we need to draw mental models. And I'll stop here, and then I will continue to elaborate more about, drawing these mental models in the next video.